Welcome to another edition of The Explainer. You know, it's so easy to think that real chemistry only happens inside massive, high-tech laboratories with bubbling flasks and crazy equipment, but honestly, there is an entire, completely fascinating world of hidden chemistry sitting right inside your home or your school. Today, we're going to unlock that world. We're going to learn exactly how to identify the chemical families hiding in plain sight, literally sitting right there on your kitchen counters and bathroom sinks. Let's get into it.
To kick things off, I want you to think about this. How can a simple piece of paper reveal the secrets of your kitchen? It sounds a little bit like magic, doesn't it? But today, we're going on a mission to decode the invisible chemical identities of everyday items. It's pure observable science. By the end of this explainer, I promise you, you are going to look at a glass of water, a bottle of soda, or even a basic bar of soap in a completely different way.
Okay, let's dive into this. What we're looking at here is the master blueprint of a core grade 7 science laboratory competency. We're going to break this whole thing down piece by piece. Our main goal? To learn how to expertly identify different solutions at home and in school as acids, bases, and salts. And we're going to do it using a very specific scientific tool.
Here is our investigation roadmap for today. Number 1, the secret litmus test. 2, acids, the sour solutions. 3, bases, slippery and soapy. 4, salts, the neutral zone. 5, the chemist's safety code. And finally, number 6, remember the color code.
All right, section 1, the secret litmus test.
To start this journey, we actually need a secret decoder ring. In the chemistry world, this is known as a litmus indicator. It's basically a special type of paper that helps identify whether a solution is acidic, basic, or neutral. It's honestly incredibly clever because it translates invisible chemical properties into the simple, highly visible color-coded language. And to do this, we use 2 specific variations. We've got a strip of red litmus paper and a strip of blue litmus paper.
Moving right along to section 2, acids, the sour solutions. So looking at our first chemical family, what exactly is an acid when we're talking about everyday life? Well, a huge clue is actually rooted in a super familiar sensory experience, and that is taste. Acids are solutions that taste distinctly sour. Think about it. But for a true, reliable scientific test, we definitely don't rely on our taste buds, we use our decoder ring. The absolute defining test for an acid is that when you dip blue litmus paper into it, that paper turns red. Let's look at some really specific examples you probably have sitting in your refrigerator right now. We're talking vinegar, calamansi or lemon juice, soft drinks, tomato juice. These are all acids. If you were to take a strip of that blue litmus paper and dip it into literally any of these common drinks or condiments, you'd see the paper instantly transform into a bright red color.
Let's hit section 3, bases, slippery, and soapy. Now let's see how this second family differs from the first one. If acids are famous for being sour, bases are often defined by a tactile sensation. They are solutions that feel distinctly slippery to the touch. Think about that weird, slick texture on your hands. And when it comes to our litmus test, they do the exact opposite of our previous group. Bases take red litmus paper and turn it blue.
And this brilliantly illustrates a fantastic memory trick for your science studies. Acids turn blue litmus red, while bases turn red litmus blue. They just mirror each other perfectly. The colors simply flip. So, if you can just remember how one acts, you can easily figure out the other.
So where do we typically find these bases in our homes? Usually they're hanging out in the bathroom or the laundry room. Think of a soapy water solution, a baking soda solution, some liquid laundry detergent, or even just a mixture of water and toothpaste. They all share that soapy, slippery characteristic, and absolutely every one of them will turn your red litmus paper blue.
Next up, section 4, salts, the neutral zone.
Okay, so we've covered the red and the blue, so welcome to the neutral zone. Some salt solutions are just perfectly neutral. But what does this mean for our investigation? It means they aren't acidic and they aren't basic. They just sit right there in the middle. Because of this perfect balance, they do not change the color of either the red or the blue litmus paper. There is absolutely no color change whatsoever. The paper just stays exactly the same as it was before you dipped it.
Everyday neutral examples are mostly just variations of water. A simple salt-water mix, a precise 0.9% NaCl saline solution, like the kind you might find in a standard first aid kit, plain mineral water, and everyday clean drinking water. If you dip your decoder paper into these, zero reaction. Blue stays blue, and red stays red.
All right, section 5, the chemist's safety code.
Okay, before you run off to test literally everything in your house, we really need to discuss professional standards. Even when we're just working with kitchen ingredients, real scientists follow strict, sequential safety procedures. Step 1. Do not taste unknown solutions. Now, I know we mentioned earlier that acids taste sour, but a real chemist never, ever uses their mouth to test unknown liquids. That is a huge no-no. Step 2. Handle all substances carefully and closely follow your teacher's instructions. And step 3. Always wash your hands thoroughly after completing the activity. Guys, these aren't just polite suggestions. This is the strict safety code that every single professional follows.
Bringing it home with Section 6. Remember the color code. Let's wrap up our investigation today with a quick final review. So, the crucial point really comes down to this ultimate cheat sheet. Acids turn blue litmus red, bases turn red litmus blue, and neutral salt solutions cause absolutely no change. If you can just commit this little chart to memory, you have officially mastered this entire concept.
I'm going to leave you with this somewhat provocative thought. What other hidden chemistry is lurking right there in your home? Armed with just a couple strips of red and blue paper and the knowledge you just picked up from this explainer, your kitchen cabinets and bathroom shelves are no longer just boring storage spaces. They are a working, real-life science laboratory just waiting to be explored. So keep asking questions, keep investigating, and stay curious.